A warm good morning to one and all. It is with immense pleasure that we welcome you all to the third day of fourth International Conference on Innovative Trends in Engineering for Sustainability Icites 2025. To commence this prestigious event, let us invoke the blessings of the Almighty with a soulful invocation. Let us rise for a silent prayer. Please be seated. Now I invite Assistant Professor Archana CP, the Organizing Secretary of Icites 2025, to formally welcome and introduce our esteemed keynote speaker of the day, Dr. Brajesh Dubey, Professor, IIT Kharagpur.
So good morning everyone. Dr. Brajesh Dubey is a professor at the Indian Institute of Technology, Kharagpur, where he also serves as chair of the School of Water Resources and leads the Circular Engineering Research Laboratory in the Department of Civil Engineering. With nearly 2 decades of post-PhD experience, Dr. Dubey specializes in sustainable and resilient systems, circular economy approaches, life cycle assessment, decarbonization of urban infrastructure, and resource recovery from waste. His work has been funded by prestigious institutions such as United Nations Industrial Development Organization, National Geographic Society, OECD, and the Indian Department of Science and Technology. Dr. Brajesh Dubey has received the Outstanding International Student Award from the University of Florida and the Faculty Excellence Award from IIT Kharagpur. He is also an associate editor and editorial board member for several journals, including those published by ASCE and ISWA. Dr. Dubey has contributed to the Clean Ganga Mission, Swachh Bharat Mission, and various governmental advisory committees on waste management and environmental sustainability. Additionally, Dr. Dubey has developed and delivered widely popular online MOOC courses in environmental science and engineering. I welcome you, sir, to attend our international conference.
Thank you, Archana. Now I invite distinguished keynote speaker, Dr. Brajesh Dubey, Professor, IIT Kharagpur, for the keynote session on Understanding Engineering Tools to Measure Sustainability Parameters.
Okay, so you, is there a slide changer or you will do the slide change? Okay. Okay, so thank you. Good morning for being here. And as introduced, I'm Brajesh Dubey. I'm a professor at IIT Kharagpur. And my core area of work has been on waste management, sustainability, circularity. That's what I try to do. And today we'll try to share some thoughts on, see, when we talk about this sustainability, what exactly as an engineer we need to measure and how to measure it, because talking about sustainability becomes many times more of a qualitative versus quantitative, isn't it? So how to measure it in a quantitative way. And one of the major tool which is used for that is called life cycle assessment. So we'll talk a little bit about life cycle assessment, and then I'll give you some examples of what we are doing. As mentioned, I do offer several NPTEL SWAYAM courses, so I have some posters of that at the end. Some of you may have already seen those NPTEL SWAYAM courses. So let's get started. Next slide, please. So before we jump into this talk, Some of you who have seen me online, my talks, you must have seen this slide, because this is the first slide I talk about in almost all my presentations wherever I'm asked to talk about. See, ultimately when we talk about this sustainability, circularity, environmental engineering or anything, ultimate goal is to keep this planet as clean as possible. Isn't it? That's the goal, is to keep this planet as clean as possible. So in terms of, is there any pointer? The pointer here? Is the pointer is there? No? Okay, that's fine. Because I could point to some numbers there, but that's okay. So in terms of like keeping this planet as clean, one thing we need to think about is what is the age of this planet. So based on research done by our geology and other friends, they suggest us that the earth is around 4.6 billion years old. And if you take that 4.6 billion and put it in a 24-hour scale, which you can see 24 hours in a day. So if you put it in a 24-hour scale, that 1 second actually becomes 52,000 years. So take 4.6 billion years, put it in a 24-hour scale, 1 second will be actually 52,000 years if you do the math. So humans as we are today, actually we have existed here for around 200,000 years. So in this time scale, we have existed on this planet for just 4 seconds. And I guess you are with me on that. We have existed just for 4 seconds. And in that 4 seconds, we have created so much of pollution, so much of problem for this planet. Not even 4 seconds. If you look at the next slide, you'll see that actually our population was not that great until last 200 years. Here y-axis is the global population in millions. Since it is in million, earlier you see almost zero there. That's actually not zero. Since the scale is like that, that's why you see almost a flat line at the bottom. It's not really zero because you are looking at 1,000, 2,000 millions. But if you look at the numbers in the last 200 to 250 years, there is a sharp increase in population. And especially after the Second World War. After the Second World War, we started producing lots of different types of chemicals. We call it anthropogenic chemicals, like man-made chemicals. We started dumping it into the environment. We started consuming also a lot. I'll show you that in a later slide. If you can, next slide please. So, and the other thing is that since our population growth is, although if you look at the rate of growth of population, which is the purple line, and green shaded area that you see is the world population. If you look at the maximum rate was in 1970s, which was around 2.1%, and then the rate is going down. Now the rate of growth of population in the world is going down, but since the baseline is so high, we are looking at that we will be around 11 billion by the end of this century. Presently we are more than 8 billion. By end of this century, we will be around 11 billion. So that's a lot of people to feed to, a lot of people for having the housing. We need to have housing for all. Isn't it? The government is trying to have housing for all. Globally also we need house, we need food, we need shelter, we need to have water for all these people. We need to collect the wastewater and treat it properly. So that's a huge challenge. From an environmental point of view, it's a huge challenge for us, especially for the students. Like I just turned 50 last year, so maybe around another 15, 20 years I will work and I retire. But the young friends who are sitting, for them actually is a huge challenge to really take care of all these population, because we have to bring food and everything for the state and make sure that the environment remains clean for them. Isn't that's very, very important. Next slide please. So what is happening is, one way you saw that population is going up, although the rate of population is going down, but overall the population is going up, and also our consumption has become, like we are consuming too much. Those of us who are older, we have, like when we were very young, most of the houses didn't have any TV, but then the early 80s we started getting these televisions and other things. But there will be one TV in the house. Nowadays every bedroom has TV. Do we really need our TV in every bedroom? We don't know. But every bedroom will have TV. We have too many gadgets at home. Our disposable income has gone up, especially in the middle class and the upper middle class. Middle class and the upper middle class, our income has actually increased quite a bit. So, in terms of how much we can buy, our buying capacity has gone up. So, we are buying things which we actually don't need. Lot of shopping mall culture. Of course, you have the Lulu Mall, the second biggest mall. Now second, earlier it was the first. Although it's a good, like I have been to that mall and it's a nice mall. But many times we go there and that celebrations, that sari store, several floors, we tend to buy stuff which we don't really need. You find that it's a nice deal, we just buy it. Probably will not use it for many months, many years, it will just be sitting there. So we are trying to we are using a lot of stuff. So overconsumption and excess waste is leading to an unsustainable planet. So when we say renewables or non-renewables, you can read that. I'm not going to read those boxes. So essentially it is talking about that we need to have better energy efficiency, better material resource efficiency. We need to use our materials properly. And we should not create waste which cannot be managed within the local infrastructure. What is happening is we are dumping lots of waste into the environment. Next slide. So if you look at the global overconsumption, this graph here, the y-axis is your ratio from 1900 to 2015, and the x-axis is the different parameters. The increase in human population growth, which is the first, your purple bar, you see the dotted line. So that's how much our population has increased between those 105 years. So around 5 times population increase. But look at the consumptions of other parameters, whether you talk about water, fossil fuel, your primary energy supply, your ores, or non-metallic minerals, huge, the bars are too tall. So it's not only the population increase which is increasing the consumption, it is the way we are living is also increasing the consumption. Whether it's a sustainable way of living, we don't know. We are creating all this waste, just dumping into the environment. Can it be like this forever? See, we talk about that, we say that there is a finite amount of resources available. Isn't it the resources which is out there? There is a finite amount. You go to Mother Earth, you mine all this copper, aluminum, iron and everything, you use it and then dump it. Create a problem for the environment. Big dumping sites, fire, you had the fire in Kochi only, a year and a half ago. With all those plastics and other waste. Is it really, is it the way we want? Because that will create more and more problem in future. So we have to do better. So we have to take this waste material after its consumption and then make it back into the economy so that we don't have to go to this mining like as frequently as we are doing. I'll give you another example. Some of you might be aware of Hatti gold mines. Hatti gold mines, we all love gold in India. Especially our southern states love more gold, but we all love our gold, isn't it? Gold is a very important stuff in our household. Hatti gold mines, which is in the border of, it's in Karnataka, but in the border with Telangana. If you come from Telangana to Karnataka, that Hampi National UNESCO site is also there. So that's where the Hatti gold mine is. They take 1 ton of ore to produce 1.2 grams of gold. So think about that. 1 ton of ore goes to produce 1.2 grams of ore. So almost 1 ton is the waste. And they have mountains of those waste lying there. Of course, I'm not saying don't use gold because that's one of the things we need. So we need to think about, so what is happening is we are producing, that's just one example of how much waste is getting produced. You go to any other industry sector, lots of waste which is there, which needs to be used properly. And they have the value to be reused as different types of material, construction materials and all those that could be done. But unfortunately we are not doing it because of, sometimes it's the lack of technology, it also lacks of the business model. I will say in today's scenario it is more of lack of business model. then lack of technology. Technology is there, but how to make that business works, it's not taking up. So as you can see, lots of overconsumption is there. Next slide. And how many of you have seen this, is aware of Earth Overshoot Day? Anyone? No? Earth Overshoot Day, again, it's a similar concept, which says that, see, every year, Mother Earth produces a certain amount of material for us. On an annual basis, we get certain amount of materials from Mother Earth, which we can consume. But what is happening is we are consuming it not on an annual basis, but even much before that. So for last year, the Earth Overshoot Day was 1st August 2024. That means that whatever the natural resources which was generated by Mother Earth for the year 2024, we used it up by the date of 1st August. So rest of August, September, October, November, December, we are borrowing resources from our reserves. So if I give you a similar example, say if you are making, say, 15 lakhs or 18 lakhs, whatever money a year, that's your salary, 15 lakhs a year. Let's assume 15 lakhs a year. So it's, if you take it similarly, it means that you are consuming the entire 15 lakhs by 1st of August. So rest of August, September, October, what you will do? You will borrow from your savings. You have saved some money for your housing down payment or for children's education. You will keep on taking money from there. If you do it 1 year, or maybe you can manage. If you do 2 years, again could be done something. But as you can see here, we are doing it year after year after year. The red bar is getting bigger and bigger and bigger. In between, there was slightly better in 2020, and I'm pretty sure you can all guess why it was. Because of the COVID period, we were all indoors. In fact, COVID told us that if one lesson you want to take from COVID, although it was not a very good period, but it told us that actually if the humans does not survive on this planet, the planet will be happier. Mother Earth does not need us. We need Mother Earth. Because when we were all indoors, actually the planet was much happier. Water was cleaner, air was cleaner. You may have seen some WhatsApp forwards which says that from Delhi you can see Himalaya. So those WhatsApp images were also coming because the pollutions were not there. So see, the Mother Earth does not need us. So if we disappear, actually sometimes, some days I feel like that if we disappear, Mother Earth will be happier. We talk about going to Mars. Personally, I feel like that we should not go to Mars. First, fix the problem on Earth. Because if we go to Mars, we'll create the same problem there. We don't deserve to go to Mars. The way we are living on this planet, actually we don't deserve to go to any other planet. First, let's fix the mess over in this planet itself. Because we've created so much of mess and we are creating so much of mess on a daily basis. So if you look at the way we are consuming, we need 1.75 Earth. 1.75 Earth, but still we all want bigger car, bigger houses, like that's what so-called American dream, but that's everything big. But unfortunately, that's not the sustainable way of living, and people are realizing it around the world. And in India also we are realizing it, but the action is a bit slower. We need to have much quicker action to solve the problem. So, as I said, if you do it year after year, if you do it financially, you will get financially bankrupt, unless you are Vijay Mallya. So you can do something on that, otherwise we'll be in a deep trouble. Similarly, if you do it for materials, here we are talking about materials. Every year we are consuming more materials than what we are supposed to consume. So at some point of time we'll have a material, like a bankruptcy, a material scarcity. And we are already in that phase. Water material scarcity, we are already in that phase right now. So we have to do better. Next slide. Urbanization is another problem which is creating, people are moving from the rural and urban. That is also creating a lot of issues, a lot of complexities. Next slide. So if you look at in urbanization, it's a 1% of the land surface, but nearly 60 to 70% of anthropogenic greenhouse gas. Anthropogenic means man-made, which is what we are making it. More population, more economic activities, demand for food, energy, water, materials. Urban areas also driving land use changes. We are encroaching into the forest. I come from IIT Kharagpur. Those of you might be familiar with IIT Kharagpur campus. It's a very big campus, 2,200 acres. It's a huge campus that is actually the house of snakes. It's a house of snakes, and in the wild we used to have fox and other things as well. Now we have built a lot of concrete stuff there, and whenever the snake comes, we think that they are coming to our house. It's actually the other way. It was the snake's house which we drove them away, and then we made houses there. See, every species on this planet has equal right to exist. It's not only the humans who have the right to exist. You need each and every species on the planet to be there. So, next slide. And same thing you see from, you may have seen some Facebook or WhatsApp where people talk about that in 5-star hotel in Karnataka, by Bangalore, one leopard came in. Actually, that was leopard's house. They cleared that jungle and made that 5-star hotel. That poor chap was coming to see what happened to his whole house. It's not that, same thing happened in Chennai. Chennai, we had at the time of independence, we had 250 lakes and ponds. Today we have less than 50. So whenever it rains a little bit, you think Chennai airport, all the roads are flooded. It will get flooded because if you fill all those lakes and ponds, where the water will go? Water has to go somewhere. There was a natural flow of water to those lakes and ponds. Now there are big DLF or other buildings where the basements gets filled up with water. Hoga hai na bhai? Because that's where the water was supposed to go. So those problems is creating a lot of issue. So almost all population growth expected in cities. So cities will require a lot of thinking in how to make these cities livable. We talk about sustainable, lot of things are there, but the more generalized word people use these days is livable. Make the cities livable. Many of the cities are not livable anymore. Talk about Delhi and all that. By 2050, we see that 70% of the China's population will be urban, 50% of the India's population will be urban, and urban growth requires additionally 100 to 200 million hectares of land, which was equivalent to what was the land used for urban areas in 2010. So by 2050 that will double. So that's a lot of challenges for all of us engineers which is out there. When we talk about these urban areas, a lot of challenges are there. Next slide. So then came, I think pretty much you must have seen these beautiful pictures earlier. Thank you. So this is your sustainable development goal. So these SDGs are, there are 17 SDGs. So if you look at many of these SDGs, whether you talk about zero hunger, good health, gender equality, clean water, affordable energy, so many of these SDGs, without your input of your engineers, it's not possible to make it happen. Isn't it? We engineers need to work towards to make it happen. Whether you are civil, electrical, mechanical, see, we make all these disciplines just to teach different but ultimately whenever you go out of colleges, for the students, when you go out of the colleges, many times you, as a civil engineer also, you have to take care of an environmental problem, like electrical problem or mechanical problem. So as you grow, you will learn those things too. Basic engineering skills is needed everywhere. So in terms of SDGs, how we are doing, of course, you should be proud that you are in Kerala. That's one of the top front runners in Kerala. Although Kerala also has a lot of problem. It's not that Kerala does not have a problem. Recently, I attended. This is my third conference in Kerala within last 4 months. I was in Kollam at TKM. Then I was at Barton Hill in Government Engineering College, Barton Hill, in just like 10 days ago. Also had what you call sadhya. So had my sadhya full lunch, and went to the temple with dhoti and all that. So and then this is the third time. So but in all the different places we came to know that there is a problem of course the environmental issues are there, the water quality issues are there, solid waste, this is my core area of work, a lot of problem is there. And compared to other states in India, of course, Kerala is doing better. This is this is the Government of India report. So although it's not a Government of India right now, many times what happens is although Central government is different party, state government is different party, but still they acknowledge that Kerala is doing good. So that's really a good part. So Kerala, most of the southern states are doing quite well. And then if you look at the north states or union territories in achiever or aspirant, so we are not on the top, we are not at the bottom, so we are kind of in the middle. Some states are doing better. So in terms of, we have to do, in fact we have to do much better to do that. So one area if you look at in terms of the sustainable development, when they talk about this, your clean energy and all that, your sustainable communities, responsible consumption, climate action, life below water, and all those SDGs, one thing which very much common for all that is decarbonization. Decarbonization term you hear a lot these days. Decarbonization is nothing but try to have lower carbon footprint. Is it lower carbon footprint? But that's kind of a subset of sustainability. Sustainability is much bigger umbrella. Decarbonization is kind of subset of sustainability. So it is used a lot these days, and then the people talk about essentially you try to reduce your carbon footprint, greenhouse gas emissions, and these CO2 methane. So there are different ways of quantifying that. GHG protocols are there. In one of my NPTEL courses, I kind of go in more detail on that. So there are different types of emissions. We call it scope 1 is the direct emissions, and 2 and 3 are the indirect emissions. So we try to measure these emissions and try to look at in terms of what's its like a harm, and then try to control it. So people are working on that already. So in terms of zero emissions, a lot of work is going on globally. One of the things is try to have more solar, more wind, eliminate coal as a fossil fuel, try to have more natural gas, zero emission vehicles, try to have heat pumps, and better building, better energy efficient in the buildings, R&D, research and development, electrical transmissions. So a lot of work going on globally. So when you try to measure this decarbonization, there are different tools are also there. They call it carbon emissions calculator, decarbonization. So one of them is the life cycle assessment. And these slides are available. And in fact, you can find it on YouTube as well. There are several talks I have on YouTube. Slides are available with sir, and you can share it, no problem. And then so we'll talk a little bit more detail about this life cycle analysis in a little while. So why this is important is that, see, when we are trying to move towards sustainability, we have to have lesser waste being produced. Whether we talk about solid waste, whether we talk about liquid waste, whether we talk about gaseous emission, we have to reduce the emissions coming out. So when you have to reduce the emissions, you have to come up with the alternatives. So when we come up with the alternatives, how good are the alternatives? How better are the alternatives? That quantification we can do using the tools of LCA. So as we move towards this tech make dispose to more linear, like a circular model, more circularity model, not create all these waste at the first place. So there we need to have more from unsustainable global economy to sustainable global economy, and lead towards what is known as a systems thinking. Systems thinking, I'm trying to explain using this cartoon. So what happens is you're driving a diesel vehicle. You are driving a diesel vehicle, you feel very dirty about it, you feel guilty about it. So because all these emissions coming out, you go and buy this electric vehicle. Now you're buying this electric vehicle, you feel very good. But electric vehicle needs to be charged. And if the charging is coming from coal-based thermal power plant, unlike our Kochi airport, it's all solar. I think that's the only airport in India, or maybe in the, I don't know, probably in Asia, maybe in the world. Maybe in the world where it's the only airport in India which is kind of generating its own electricity and all that. Solar panel also has its own problem. See, solar panel, manufacturing of solar panel also requires lots of rare earths and other elements. So there is a carbon footprint associated with that. And management of solar panel waste is also an issue. Management of once after it, say during when you set up the solar panel, there will be some breakage. Now they contain a lot of heavy metals and other stuff. After its life, what to do with the solar panel? When during its operation, if it gets too much of dust, so you have to clean that solar panel. If you use water to clean it, so what will happen to the wastewater? So solar panel is a good thing, but that also has certain carbon footprint and environmental footprint associated with that. So we need to, but here it's what is happening is you're transferring all these emissions from here to here. and sometimes much higher emissions. If you have an electric vehicle, on average, for around 250 kilometers charging is there for most of the electric vehicle nowadays, 200 to 250, 300. And the energy required to charge that electric vehicle is equivalent to almost 25 times of refrigerator, the big refrigerators, the 300 liter ones. Now most of the houses are the big ones. 165, 175 is out of fashion. We all have big double door, triple door refrigerators at home, and sometimes multiple refrigerators at home as well. So the big refrigerators, how much energy it consumes, the 25 of those refrigerators, that much energy goes into charging this car. And if you use entirely this coal-based thermal power plant, that also, it's a solving the problem in terms of the lesser air pollution in the cities, but it will increase the air pollution wherever the coal-based thermal power plant is there. It will increase the pollution wherever the coal mining is there. Because if the energy demand goes up, more coal mining will be there. In fact, just day before yesterday, the government of India, the Ministry of Coal, put up a tweet with a picture that I think this last financial year, we had maximum extraction of coal ever happened in India. So although we are working a lot on solar, wind, but still, since India is growing, we need energy. Still we are relying a lot on the coal-based thermal power plant. And I think for next couple of decades, we have no other option, but we will be relying on coal-based thermal power plant, because that's because of the demand for energy that we have. So we need to make sure that there are ways to fix this problem. If the coal-based thermal power plant have proper air pollution control system, they do run their electrostatic precipitator. I have visited several plants where they have those air pollution control system, but they don't run it. Don't run it just to try a little bit of money, just to save a little bit of money. That's not really proper, because you are adding a lot of cost, environmental cost, human health cost to the people. Sorry. So in terms of so that's where, to avoid all that, to avoid this, we need to start having this systems thinking. So system thinking says that you try to look at the whole thing in a holistic way. Rather than looking in a silos way, let's have a holistic picture. And that's where LCA comes into consideration. These are all taken from ISO document. So what LCA does, which is called life cycle assessment, it addresses the environmental aspects and potential environmental impact, how much for the use of resource, environmental consequence of release, through a product's life cycle from raw material acquisition through production, use, end of life treatment, recycling, and final disposal. So you have to look at the entire value chain, from mining all the way to final disposal, to the waste management systems, or resource recovery from waste and bring it back. Earlier we used to say cradle to grave. You may have heard the term cradle to grave, which is used for our environmental system, any material system, from mining all the way to disposal. Now we don't say cradle to grave, we say cradle to cradle, because we don't want waste. We want to recover material from waste and use it back into the economy. That's what the circular economy is, isn't it? Circular economy is no waste. So we move towards zero waste. So it becomes more like cradle to cradle. So there LCA helps us to understand what will be the carbon footprint, real carbon footprint of different environmental processes. So there is an ISO methodology where you have to have a goal and a scope, inventory analysis. So this is a typical methodology of how the LCA is done. I will give you some examples. I will go through some examples, like a couple of examples, which will make things clearer. And those of you who want to learn it more, there is an NPTEL course available. Courses are available on YouTube, where we talk in detail for 10 weeks, or 10 weeks, every week 5 hours. Which I will try to talk in the next 30 minutes. So in terms of what actually is this LCA is all about. So it helps in terms of product development, planning, public policy, marketing, and other things. Why LCA? You can have better product, less carbon footprint product. Nowadays many governments are asking for your LCA certification. Any product you will sell in European market from 1st January 2026. In European Union, any product, process, or any softwares you will be selling, that requires LCA certification from 1st January 2026. So those of you who wants to open your own business, the students I'm talking to you, if you get the LCA certification, you will make a good money working from home. Because that's a very hot area coming up. Because for example, if I'm running a company, I want to get my LCA done, I can approach IITs or colleges like here, anybody who is an expert, they can do the LCA for me. But that LCA has to be certified by those people who are already certified, like who can vet the LCA. Vetting of LCA has to be done. And there is a course for that. You have to get from an international organization, you have to pass that exam and become certified. And if you become certified, I'm sure your career is set, because there will be a huge demand for this in next couple of decades for sure. So, and for identify improvement and liability and all that. So before we jump into LCA, I just wanted to pick your brain with few examples. So if you look at these two products, A and B, which you think is good for environment? A is good for environment, isn't it? Now, but if you do the carbon footprint calculation of A and B, which will have higher carbon footprint? A will have higher carbon footprint. Because it's a lot of materials, lot of things has gone into making A. So when we do life cycle assessment, if I compare just one of this versus one of that, this guy will lose out, isn't it? Because it has a high carbon footprint. So we don't compare one of this versus one of that. How we compare? What is the purpose of both of these? To serve some dessert, serve some drinks, coffee, tea, or maybe water or Coca-Cola, whatever. So some sort of beverage. They will serve. So what we say that we will take, so function, that is called function. If you look at that, here the goal and scope and all that. So there is something called function, there is something called functional unit and all. So that's what I'm trying to explain. So function for both of these products is to serve drink, some sort of drink. Functional unit could be for serving the drink for a month. Now if I'm serving for a month, every day three times drink, just is a coffee, tea or whatever, 3 times assume or 5 times, whatever is common. So you can take 3 times or 5 times. So let's say 5 times. Every month 5 times means 30 days in a month, you need 150 of those. 5 times 30, 150 of those. You need only one of this. Isn't it? You need only one of this. In between you need to clean. You will clean it 149 times. In our colleges, hostels, sometimes we don't clean for many days. And sometimes we can multiple use also of this one, but I'm talking about more common stuff. You have to clean it 149 times. There will be some water used, there will be some hot water also used, there might be some usage of detergent also for cleaning. So all those things you will take into consideration. So for a month, if you are using this versus this, so what is the carbon footprint of that? So that will give a fair comparison between these two products. Otherwise this chap will always lose out. So that's the purpose. When you take LCA, you don't do one product, but you look at the kind of a more, what is the function of the product and what is, how long you want to use it. Even you can do it for any product for that matter, even camera or this particular pointer. You can do LCA for any product, chair, table, everything we can do LCA for. So another example between these two, which one is better? Which one is better? B is better. But how much better? Nowadays also LED is also there. LED bulbs in fact better than B. Some of the initial, these ones had actually had a higher mercury than this. So that is also, this is definitely better, but how much better? How to quantify? So that is also, when we go for quantification, then another, sometimes what happens is, when you are looking at this versus that, one thing is of course to provide light. That is its primary function. Secondary function is also to create ambience. So you go to any like a chudi store or other those stores, they will have too much of LEDs. Even sari stores and all, you will find lots of LEDs. You look at the product, they look different when you come to home because they look so shiny there. So that creates an ambience. We cannot quantify that ambience. So we don't worry about that. We just say from the energy point of view, energy usage point of view. What is, so we just focus on that, but there are other, that's called secondary function. So where the primary function is to provide light, secondary function is also to create ambience and all that. Many places this is still being used. You know why? Because it has more warmth, more heat comes out from there. Especially the chicken farms. Chicken farms are still using this bulb because they need warmth. They need warmth for, so they still, although it's energy-wise, it's, so there are always exceptions. Now these two guys, this A versus B, which one is better? A is better or B is better? Some are saying A, some are saying B. So, actually if you go by the manufacturing, I'll just take you. If you look at the manufacturing, just the manufacturing part, actually A is better. A has the lesser carbon footprint. The plastic bags have the lesser carbon footprint than paper bag. In fact, if you go on the YouTube and look for ads from 1970s, when the plastic was coming into the market, people were talking about that let's save the forest. Let's move to plastic and save the forest. Because this paper is actually coming, the raw material is coming from the forest. But what we did actually, we have totally messed up the plastics. Plastics, we have created a mess out of it. Plastic is actually a wonderful material. Plastic as a material is very good. As a human, we have totally misused the plastic as a material. We have abused the plastic as a material. See, look at this material here, these things, many things, from morning to evening. Most of the stuff we use has plastics. But we have created so much of single-use plastics. Nearly 40% of the plastic used is single-use. All those wrapping material and everything, we use it and we just throw it away. We don't manage the plastic waste properly. Problem is there. Plastic as a material is not a problem. It is a problem is of plastic waste, which should have been managed properly. Plastic waste from the industries, plastic waste from our household, plastic waste from different places, wherever it is being used. Otherwise, if you look at plastic, actually, if you look at the cars today, cars have good amount of plastic. Good amount of plastic means cars have become lighter. Lighter cars means better fuel mileage. Better fuel mileage means good for environment. Go to any mall, you have all these food like sugar, salt, everything is now nicely packed in plastics. Earlier, those of us who are older, we have seen they used to be in the jute bags. And during the hot, humid monsoon season of Kerala, you will have all those salt and sugar becoming clumsy and all that. Now, and then we used to a lot of wastage of food as well. So plastic actually helped in increasing the shelf life of those products, reducing of the food waste as well. So plastic has done a lot of good things for us, but unfortunately we have totally misused the plastic waste. Especially the plastic waste management, we have totally messed it up. And that's the reason we have a huge problem of plastics. And you might have seen a lot of videos and other things. So this, when it comes to the disposal, becomes a huge problem. This one again, if you can compost and all, it's considered better. So LCA, what we do, first of all, we look at what is the goal and scope, and then we try to collect data. And after collecting data, we do the impact analysis and then try to interpret. So I'll give you some example. So in terms of, we take all the compilation and evaluation of input, output of the potential environmental impact, done as per the ISO method. Why to do it? We already kind of talked about that. So this is a very important slide. If you understand this slide, this is the basics of how LCA is done. If you understood this, rest of it is just kind of follow up. So you start from the raw material acquisition. For any product, material, whatever you make, you need raw material. So from the raw material acquisition, processing of the material, manufacturing, assembly, use and service, retirement recovery, and then finally treatment disposal. So all through you have material and energy going into the process, and we create all sorts of waste. So what LCA does is collects all the data for this M, E and W. And getting all this data and then correlate it with the different environmental impact that it may have. As per the IPCC document, Intergovernmental Panel for Climate Change, IPCC, which is more the guiding document for all these climate change, global warming and other things right there. And So we kind of look at each of those and come up with this profile, and then after that, in terms of data collection, we already kind of talked about function and functional unit. You also need to somehow decide what is the boundary. Let's look at the example that will make it more clearer. So you look at all those inputs and outputs. Data collection, it has to be time sensitive data. Like what is the last 5 years data, geographical data, best possible technology, representative data, consistency data. And then after you get all those data, you relate it to this global warming potential, abiotic depletion. So there are totally 17 impact assessment categories out there. Different different environmental impact categories we looked at. Eutrophication, acidification, and all those kind of stuff. So once you have all that, based on your LCA results, scientists can make recommendation. Scientists can also analyze particular impact. Industry and individual can take a closer look how they can make a difference. Let's look at an example first, then we'll come back to this. Okay. Okay, it's not here. Oh, okay, it's not. Anyway, I think so in terms of, I thought I had an example, maybe or not. Okay. Okay, I'll tell you that example anyway. It is there or not. Looks like no, it's not there on this set of slide. Never mind. I'll go over that in a minute. I'll give you examples by going back to this. So for example, let's go back to this slide. Yeah. So say if you have to do a comparison between the two products, you have to do comparison, say two bulbs that we talked about. Those two bulbs that we were talking about, if you have to compare those two bulbs. So first thing what we do is to find out why this LCA is being done. Why this LCA is being done? Of course, the first thing is to kind of look at how the carbon footprint of this LED bulb is lower than the incandescent bulb. So that's the purpose of that. How much energy will be saved? Then where that energy is coming from, where the energy is coming from, and that what is the source of energy, which is a coal-based thermal power plant, which is a renewable energy and all that. So what is the purpose of LCA and who is the audience? That's very, very important. Then when you look at this bulb's function is to provide light. So we take the example, say you have to provide light for a 1 month. For a 1 month, how much energy consumption from incandescent versus LED bulb. So you take a certain example in terms of in terms of how much energy will be used and all that. Then you have to come up with a boundary. I think it will be better. Can I just from my slides, can I copy another file? I thought the slides were here, but it's not here. So I'll just one LCA example is there. So I'll just, if you give me, because that will be better. Otherwise, you will get confused what I'm trying to say. Yeah, pen drive, just for a second.
May not be copied.
Huh?
May not be copied.
No, I think I copied the older version, not the newer version. When copying, I had few versions. Like while I was working on it, I had couple of versions. By mistake, I copied, looks like the older version of the file. Just give me a couple of minutes, it will be there. Okay, another 20 minutes? Yeah. Another 20 minutes? Okay, yeah. Yeah. So we'll go to that slide for just a little while. I'll just go and talk, and then we'll come back to the first presentation. This is another file.
Yeah.
Okay. Because that example, otherwise they will not get the picture. Okay, sorry for that. So I just wanted to walk you through this example so that you know how actually LCA is done. See, if you have to compare these two light bulbs in terms of which is worse, equal or better. So first thing, I already told you that you have to have these 4 stages of, this is basically as per the ISO methodology, and then we look at what is the impact on Mother Earth. That's the ultimate goal we do. So in terms of the life cycle of a light bulb, you kind of start from the bulb. So these are all these different materials in terms of making of those bulbs. Isn't this is how the bulb is specially made. So these materials has to be extracted and transformed. So that's called resource acquisition. And then you have to, after you make it, you have to package it, you transport it. Then it goes for electricity, you use electricity to use the light. And then finally, end of life, it will get disposed. So from all the beginning to the end, so this dotted line is basically gives you what will be the scope of the LCA. So this is the system, we call it a systems boundary. So what is, because you have to stop somewhere, isn't it? You cannot keep on going, because otherwise you will do it forever. So you have to look at from the like extraction all the way to the end of life. So this is your, this is known as the system boundary for that particular stuff. And the bulb's function is lighting, and then taking that particular product. So you have all these different input that goes into making of the stuff, iron ore, crude oil. These are all the outputs, emissions and other things coming out, and we do it for a particular functional unit. Functional unit, if you can talk about, so if you have to the functional unit here, so you have 2 products here, incandescent light bulb, compact fluorescent lamp. So primary function is lighting, secondary function is heating or creating an ambience. You will not worry about that. So in terms of functional unit, say if we say that we provide 700 lumens of light for 10,000 hours, so for those, to make this happen, you need 10 bulbs of incandescent and 1 bulb of CFL. So this number I have chosen. This number I have chosen, and I have chosen it such a way so that I get a nice number here, 1 bulb and 10 bulb. So my calculation will be easier. So you can choose that number, but number has to be same for both the bulbs, because both the bulb is providing the light. And then you can do the lifetime Wattman ratio as well. So then you have to do this inventory. Inventory where you look at in terms of providing 700 lumens, 10,000 hours. So you need how much of, how much glass is needed, how much cardboard is needed, how much energy is needed to glass for making that bulb. So for 1 kg of glass, so these kind of data is already available in the softwares nowadays. For LCA we use different types of softwares. So there are databases associated with that. So these kind of data is already available. So you get this data from those stuff. So you get all these data, and from this are your, for 1 kg you need 228 gram. So for 1 kg this much, how much is for 228? So you kind of calculate based on linear, you just do a linear math, and you get all those numbers. So these are just some of the values are given, like how much CO2 emissions, how much particulate matter, how much benzene. Of course the list is long, This is just to show you the example of how it is done. Most of these are actually done by the softwares today. But you need to understand what the software does. Isn't it? Because otherwise, at the end of the day, we are responsible for whatever the calculation we are making. So this is what typically done in terms of, so they will calculate all these emissions, and on these emissions, they will try to relate it to different, so these are the places where you can get those softwares. Sorry, databases. So there is a central database, different organizations are putting those data in the central database. There is a Eco-Invent is also there, which has the database. From India also we have lots of data in the Eco-Invent database. And then once you have the data, you relate it to all these different kind of impact categories, which is as per the IPCC document. And then you look at all those respiratory disease, seawater level, cancer, dying forest, reduced use and all that. So from the elementary flow, you get all these 17 categories as per the IPCC document. Then you look at the impact on human health, ecosystem, climate change, and then finally you come up with a single score, and that single score kind of similar to your you always, those of you who are interested in the stock market, there is a census. We have an air quality index, we have a water quality index. So these are all single score. Isn't it? So here also we create a single score so that it's easy to communicate to the people. Otherwise, if I go to the people and tell them individually all these numbers, they will get confused. Because as a LCA person or as an environmental engineer, those who study this, we can understand that. But if you want to talk to politicians, our bureaucrats and all, they will ask you which one is better. Just tell me which one is better, how much it will cost. If there is a problem, how much it will cost to fix the problem. So you need to give them a single score on that. So this is how the typical LCA is done on for any product. So just wanted to walk you very quickly. Those of you who are interested, you can always go back to that YouTube set of lectures which is already there. If you just go on YouTube, put life cycle assessment and my name, you will find the whole video list which is there. So we already talked about all that. So we can skip. So let's, and another concept which is coming up is in terms of these days is on a concept called circular economy, which we kind of talked about. Next, what the circular economy says, let's design out waste and pollution. So those of you who will be graduating in a year or two from now when you go to the industry, now there is a huge demand for having a better product with lesser environmental footprint. Lesser environmental footprint means lesser waste. So have a thinking towards more circularity. And there are a lot of work going on in this area as well. Circular economy, if you are really interested, this is one website which you can go to, Ellen MacArthur Foundation, where they kind of talk about that let's not create any waste. So you see lots of circles coming back and try to minimize the waste as much as possible. So when you talk about the circular economy, how to measure circular economy? See, talking about it is very nice, but how to, as an engineer, as a scientist, we always need numbers. Without numbers, we cannot make any decision. So, how to measure it? So, there is a work going on in India right now with Niti Aayog and other organizations, where you look at all these different resources, water, environment, and then we look at in terms of how much renewable non-virgin content, how much of the critical minerals, how much of your hazardous material, how much is the reduction in hazardous material, what kind of processes are being used. So, based on this, we try to quantify and we give a number in terms of what is the circularity of any process. So, life cycle analysis, analytical hierarchy process, GIS and a lot of other tools, say all these are being used in what is known as the systems engineering today. Systems engineering says is more holistic approach. So in terms of this aspect, one example of one product where we are trying to incorporate this circular economy principle is try to use this food waste and create some value added product from that. So what we are trying to do is we take this food and yard waste and then we do this hydrothermal carbonization and then produce this what is known as the hydrochar pellets, and those hydrochar pellet can substitute coal. So wherever the coal is used, we can use the hydrochar pellets. We can also use this as a carbon material. We can use it for energy storage material and all that too. So when we make this hydrochar, we use a lot of water. So instead of using the pure water, can we use wastewater? So we kind of looked at that aspect as well. So you use this hydrothermal carbonization of material, you make this hydrochar. This hydrochar could be used in energy storage. Now when I'm talking about energy storage, most of us use a smartphone today. So this smartphone, whatever you need a battery. Battery needs a lot of graphitic carbon. So the graphitic carbon can be manufactured from food waste. We should not create food waste. But if you create food waste, it can be upcycled this way. If it upcycled this way, then there will be a market for it. And in the market for it, then the business will come. So that's how we need to bring the circularity. So those are some of the work which is being done. So anything food you waste today, after 2-3 years, it is there in your new cell phone in a different form. So those kind of things brings a lot of circularity. So hydrochar could be used for multiple application, as I told you earlier. So this work we have been trying to do in our lab, and it has got a lot of media attention as well, where we try to food waste, yard waste, lots of yard waste are actually all those broken trees and twigs and other stuff. In Kerala is full of that. And Kerala is a huge tourism industry. So tourism industry means a lot of catering, lot of destination wedding also happens here. So a lot of food waste is also there in this particular state. So some of the papers published on there. Then another areas where we do a lot of work these days in try to startups. We try to help startups do better. So there is one Material Recycling Association of India. We work with them in terms of making their whatever the startup ideas to help them technically, also sometimes economically as well, from some funding agency. So those of the students who are finishing up your BTech, wants to go for MTech or PhD, if you want to come to our lab, we work on these areas these days, and even we are trying to do, we take a lot of kitchen food and yard waste and others and create a lot of different value added product from there. Some other work in terms of energy application, try to have, as I told you already about hydrochar. Hydrochar, when you do this hydrothermal carbonization, this is a hydrothermal carbonization reactor, you have a solid phase and a liquid phase. Taking the liquid phase, we are also producing bioplastics. In fact, the student who is doing PhD on that, Anjali Thomas, she is from Icites, which is not too far from here. So this is we get good amount of Malayali student in our MTech and PhD program. And right now I have 3 Malayali students. One of them getting married in Guruvayur temple in a couple of months from now. So again, in 2 months from now, I will be in Guruvayur temple for his marriage. So because I've been there before as well. So this is, then as I told you earlier, we are also working on some microalgae, producing this biocarbon, then biocarbon electrode used for energy storage and all that. We are using sugarcane waste to produce hydrogen. So this is just for the students' benefit. If you are interested to any of these projects, you can come to us. We are also doing some modeling work in terms of try to understand these processes better. So I'll go a little bit faster for the interest of time. I think we already talked about all these things already. So there is a project where we are working on water sludge and try to do this what is known as aqueous phase reforming to make hydrogen gas out of that. This is the Anjali Thomas's work, which is we are taking this like a liquid phase, then using the bacteria, we are producing this PHA, and then looking the environmental impact of the PHA, and doing some composting and other stuff. We do this in collaboration with our biotech department. Professor R.K. Sen is our collaborator. We have also done a lot of work on plastic waste in the past, try to make some value added product from plastic waste. Whenever we go for this lignocellulosic biomass, lignin always becomes a problem in terms of production of this biogas. So that we try to breakdown of the lignin can be done using different pre-treatment technique. So we have developed an enzymatic pre-treatment technique which we are using, this lactase mediated enzymatic pre-treatment technique. This has been developed in collaboration with our one of the professors in the agriculture and food engineering department. Then life cycle analysis, I already told you. We have been working with many of the cities in India in terms of solid waste management for their life cycle analysis and all. A lot of work is going on in the plastic waste side as well. Some of you may have seen my plastic waste course. So as I was telling you earlier, this sustainable engineering concept and life cycle analysis, this course is available. It was running right now. March 22nd was the exam. It's running since 2017 every year. So that's you can find this in the YouTube. Similarly, the course is there on the integrated waste management, plastic waste, electronic waste, and a basic course on environmental engineering and science. And that's my like a research group, my students. So this gentleman, Unni Krishnan, he is getting married in Guruvayur. And Anjali, where is Anjali? Anjali is here, there, right there. So she's, so all these students who work really hard on different projects. So thank you. And yes, I had to rush through a little bit for the interest of the time, because you have, I think, other classes, other presentations as well. But if you have any questions, feel free to ask now. You can always get in touch with me. That's my WhatsApp number. I will, if you need to get in touch, you can always write to me. I will definitely respond. I may be a day or two late in responding, but you will definitely get the response back. So thank you. And if you have any question, we can take that.
Any queries from students side?
Nowadays, the students are always very quiet. You can ask anything. No question. Even you can talk about, I think all of you are finishing your BTech, Bachelor's of Engineering, isn't it? You can even ask whether how good is the MTech program in Kharagpur, if you want to do PhD, or even if you want to go abroad. I did my PhD abroad. I stayed in, I was in US, Canada for nearly 15 years. So whatever query, if you think I can be helpful, you can feel free to ask. They're all very So,
if there is no queries, we shall proceed. So, your enlightening talk provides us with valuable insight on Earth Overshoot Day and how to measure the sustainability in a quantitative way. Sir has highlighted the key tools such as SDG goals and LCA, and also given insight into decarbonization, carbon footprint, circular economy by highlighting their roles in evaluating the resource efficiency, reduce emissions, and promoting sustainability with very good interesting examples. Thank you, sir, for sharing your expertise and inspiring us to think critically about sustainability in our work. And also, we thank for sparing your valuable time with us. Next, I invite Professor Dr. Vasdev R., convener of Icites 2025, for handing over a memento and a special gift to Dr. Brajesh Dubey, Professor IIT Kharagpur, as a token of our love and gratitude. Thank you, sir. Once again, thank you all. Technical sessions will be starting soon. Now it's team break. After that, we will start.